Okay, so we've graphed a bunch of functions that have a domain. Now we're going to graph some without a domain. So no x's will be given. There's 6 steps to remember. Again, remember, rearrange so y equals something. This time, you're going to pick multiple independent values for x. I usually pick 2 negative, 0, and 2 positive. Please have that many. So you need 5 total. Then substitute in the independent values, write as an ordered pair. Plot your ordered pairs. This is a big step that's different. Now you connect your line or your curve. And the reason why you connect here is because you might have picked a completely different independent value than the person next to you, and you want to include all of them. So let's go ahead and do that. First of all, we have, for number 4, we have negative 3x plus 2 equals y. I'm just going to flip it around so we have y equals negative 3x plus 2. Then I'm going to pick my values for x, y table, and again, 2 negatives, 0, and positive. I usually pick negative 2, negative 1, 0, 1, and 2. This isn't a domain. You could pick negative 5, negative 6, whatever you want. Now let's show our substitution plugging it in. So we have y equals negative 3 in parentheses times negative 2 plus 2. Negative 3 times negative 2 is positive 6 plus 2 equals positive 8. I'll put it in my chart. Let's substitute our next one in. Y equals negative 3 times negative 1 in parentheses plus 2 equals negative 3 times negative 1 is 3 plus 2 equals 5. So negative 1, 5. Third one, y equals negative 3, still keep it in parentheses, times 0 plus 2. Negative 3 times 0 is 0 plus 2, which gives me 2. Plug in our 1. Y equals negative 3 times, in parentheses, 1 plus 2 equals negative 3 times 1 is negative 3 plus 2. Negative 3 plus 2 is negative 1. Last but not least, y equals negative 3 times 2 plus 2. Plug it in. Negative 3 times 2 gives me negative 6 plus 2, which equals negative 4. Now let's go ahead and plot them. 1, 2, 3, 4, 5, 6, 7. I know y has to go up to 8, so I'm just going to put an 8 up here. 1, 2, 3, 4, 5, 6, 7. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. So we have negative 2, 8. Negative 2 up to 8. That's why I added that extra one. Negative 1 up to 5. 0 up to 2. 1 down to negative 1. To the right 2 down to negative 4. And since you got to pick your ordered pairs, you got to pick whatever you wanted for x, we want to include, because the person next to you, they might have picked 3. So you want to connect them with arrowheads. Put arrowheads because your line extends forever and ever and ever and ever and ever and ever. That's huge. You'll miss a half a point if you don't have arrowheads. Otherwise, that's a segment. These are lines. Number 5, we have f of x. F of x is the same thing, remember, as y. So we have y equals the absolute value of x minus 4. Let's go ahead. Let's pick some x values that we want to put in. Again, I'm going to pick negative 2, negative 1, 0, 1, and 2. So let's go ahead. And instead of using this, I'll just substitute it in using my function notation so I'm getting used to it. So I have f of negative 2 equals the absolute value of negative 2 minus 4. The absolute value of negative 2 is 2 minus 4, which equals negative 2. So my y was negative 2. Remember, this is saying, what is y when x equals negative 2? Here, let's plug in our negative 1. F of negative 1 equals the absolute value of negative 1 minus 4. The absolute value of negative 1 is 1 minus 4, which gives me negative 3. Plug in my negative 3. f of 0, plugging it in, absolute value of 0 minus 4. Absolute value of 0 is 0 minus 4, gives me negative 4. Plug in my 1. F of 1 equals the absolute value of 1 minus 4. Absolute value of 1 equals 1 minus 4. 1 minus 4 equals negative 3. Last but not least, f of 2 equals the absolute value of 2 minus 4. Absolute value of 2 is 2 minus 4 equals negative 2. Right away, since it's absolute value, you know this is going to be a v. So now let's go ahead and plot them. Negative 2 to the left, 2, negative 2, down 2. Negative 1 to the left, 1, down, 1, 2, 3. 0, negative 4, oops. 0, negative 4, 1, negative 3, 2, negative 2, and again, connect them with arrowheads because you could pick whatever you wanted. There was no domain. Number 6, we know it's an x squared, so we know it's going to be u-shaped. I'm going to change something about this though. This negative x squared, remember it's g of x equals, I'd write this as negative 1 times my x squared plus 5. It just helps me to realize that it's negative times that. And again, let's make our table xy, and let's choose negative 2, negative 1, 0, 1, and 2. When you substitute in, again guys, remember it's so important to put it in parentheses. So I have g of negative 2 equals negative 1 times, in parentheses, negative 2 quantity squared plus 5. Your negative's inside the parentheses, so negative 2 times negative 2 is positive 4 times your negative 1 plus 5. Negative 1 plus 4 is negative 4 plus 5, and you get positive 1. So negative 2, positive 1. G of negative 1, same thing, negative 1 times in parentheses, negative 1 quantity squared plus 5. Do my squared first. Negative 1 times negative 1 is positive 1 plus 5. Negative 1 plus 5 gives me 4. So we get negative 1, 4. G of 0, we have negative 1 times, in parentheses, 0 squared plus 5. 0 times 0 is 0, so we have negative 1 times 0 plus 5, which is just 0 plus 5, which gives me 5. So we have 0, 5. Plug in my 1. So we have g of 1 equals negative 1 times 1 quantity squared plus 5. 1 squared is 1. Negative 1 times 1 plus 5 is negative 1 plus 5, which equals my 4. I don't know if you start to notice a trend, but 5, 4, 4, 1, I bet you know what comes next. It's a 1, and you're right if you substitute it in. So let's go ahead and plot it. Negative 1, 2, up 1. Negative 1, up 1, 2, 3, 4. 0, up 1, 2, 3, 4, 5. 1, 4, 2, 1. And it did make a U. Again with the arrowheads, again connecting, because you could have picked whatever values you wanted for x to plug in. Again, make sure substitute in using parentheses. That's huge. That is so important here. Let's do a word problem now. It says the fastest Hawaiian lava flow moved at an average speed of 6 miles an hour. The function y equals 6x, I'm going to write this real quick, y equals 6x, describes the distance y the lava moved on an average in x hours. Graph the function. Use the graph to estimate the miles after 5.5 hours. The first thing I want you to do is define x and y. We know here it's distance y, and it says x hours. So x equals the hours, and y equals the distance. What is the distance in? It says average speed of 6 miles per hour. So my distance would be in miles. That's mi. So we can pick whatever values. It doesn't say specific x's. So I'm going to make a table. Do I need to pick negative x's? No. No negative x's because my x is hours. You can't have negative time. So I'm going to pick some simple ones. And now I'm thinking about it. I have to multiply it by 6. And I know that I want to find after 5.5 hours. So I probably want to do an x value that's bigger than 5.5, but is, multiplying it by 6. So maybe after 0 hours, 1, 2, and then I might not do 6 hours just because 5's between there. Okay, so let's go ahead and substitute them in. Y equals 6 times 0, well that just equals 0. Y equals 6 times 1, well that just equals 6. Y equals 6 times 2, well that equals 12. And y equals 6 times 6, well that equals 36. Now we can go ahead and make our graph. Make sure you label your x and y axis. X-axis is your x. So it's the number of hours. And your y is the distance traveled in miles. Make sure you put that on there. A good title might be Hawaiian lava flow. Now let's think about how we want to scale our x and y axis. Our x's, we went up to 6. If it's less than 10, go by ones for a scale. So we'd have our x-axis down here. I'll just make it right here. Our x-axis down here. Our y-axis up here because we don't have our negatives. So we'll have 1, 2, 3, 4. You know what? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There's more than double my 6. So I'm actually going to skip a line so it's a little spread out better. So skip a line 1, skip a line 2, skip a line 3, skip a line 4, skip a line 5, skip a line 6, skip a line 7, skip a line 8, skip a line 9. Now, so if there's 18 there, there's 18 here, but I need 36. So if I do 36 divided by the number of lines that I had a total of 18 lines. Well, 36 divided by 18 is just 2. So let's go by 2. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Oh no, I wasn't quite there. Let's just add it up here. 34, 36, make our lines there. So it's going up. I might even just add it. So they're across there. Now let's just go ahead and plot. We have 0, 0 down here. We had 1, 6, 1 up to 6, 2, 12. Oh, my 1 wasn't right there. I skipped a line. 1, 6 is right here. 2, 12 is right there. And then we went all the way over to 6 and all the way up here. And I would want to connect it because I could have picked any single one of those. With an arrowhead on the top. That's huge. Now if it says after 5.5 hours, I'd go over to 5.5, 5, 6, 5.5 is in the middle, go up to my line, hits it there, go over, and I'd write a sentence that after 5.5 hours, the lava went about 34 miles. And that would be the answer. Your answer would need to be a sentence like that.